So the last property of logarithms that we are covering here is the change of base formula. And that formula is a very handy formula to have if you have an older calculator, because older calculators either have just the log, that means logarithm to the base 10, or ln available, that's logarithm to the base e. But you might want to sometimes find logarithms for other bases, like in these examples below we have logarithm to the base 2 of 5 and logarithm to the base 4 of 15. Now how are you going to do that if you only have logarithm to the base 10 or e available? Well, that's where the change of base formula comes in. You can actually change to a different base with that formula, and that is the most general form is given up here, where we say that logarithm to the base a of any expression or number m can be rewritten as logarithm to a different base b of just m, and then divide that by the logarithm to the same base b of the number a that was formerly the base. So you're basically simply dividing the logarithm of n and the logarithm of a to any base you like. Now below we have it rewritten that same formula one more time in the, or two more times in the way that you, if you apply them, most likely are going to apply them, which is that you're going to use as your second base then base 10 in this case. So logarithm to the base a of m would then be rewritten as logarithm of m and logarithm of a. Or you can do the same thing with the ln. So logarithm to the base a of m can be rewritten as ln of m divided by ln of a. So how does that look in action? Well, let's take the first example, and here we're gonna use the logarithm to the base 10 at first. So we rewrite this logarithm of 5 and divide that expression by logarithm of 2, because 2 was our base just now. And now you can take any calculator and find that, and you will get that you have to round, and so therefore we are writing rounding signs, and then 2.322 would be a good approximation. Now try it out and see what happens if you, let's actually write it next to it, if you work the same problem as with ln. So let's say logarithm to the base 2 of 5. Now what will happen if we rewrite it with ln of 5 and we are dividing that by ln of the base 2? And if you plug that in your calculator, voila, you again get 2.322. So these are two different ways of writing or finding the same answer. And both works any base you can work. If you have a more modern setup, then, and you can find for any base, you can try out, play around with different bases there. Now let's take the second example also, and we again, so to help you get used to the ln, I'm going to use ln in this case. I like it because it's less to write, one letter less to write, and so it's a little quicker. And I divide by ln of the base 4, and then when I type that into my calculator, I get 1.953 as an approximate answer. And so you can use that for any logarithm you ever need to find that is not already in the base 10 or to the base e.